Okay, so the second proof that is on page 32 in your notes, we have to understand a theorem that we did not cover, that we did not go over. I briefly talked about it, but I want to go through and explain the theorem. This is on page 29 in your notebook. It's a purple sheet, and I wanted to go ahead and fill in the rest of the notes for this particular section. Okay, so we did not fill in these two, and I want to go ahead and fill those in because the proof I'm about to do goes with the three parallel lines theorem. Okay, so the three parallel lines theorem makes a lot of sense. Okay, this will not be something that you'll go, what? I don't understand how that's possible. This will make clear sense. Okay, the three parallel lines theorem says if two lines are parallel to the same line, then they are parallel to each other. So if I have two parallel lines, let me label these. For example, if I have line A and line C, and they are parallel to B, then A and C must also be parallel to each other. And that's a little bit more like a duh theorem. We've talked about those. That's clearly obvious. They're all three parallel, right? But this is just a way of stating it so that you understand that if A is parallel to B and C is parallel to B, then A and C are parallel to each other, okay? Which, if you think about some of the properties we've learned, is going to sound a little bit like the transitive property, which is one of the properties we're going to use in that proof. All right, now let me go ahead and give you this one. We don't necessarily have to know this one for the proof we're about to do, but I want to give it to you anyway. So this is the perpendicular and parallel lines theorem, and this makes sense too. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. Okay, so I'm going to draw a line, and I'm then going to draw two other lines that are perpendicular to that line. There's one, and there's one. And again, perpendicular means they have to have 90-degree angles. Well, if B is perpendicular to A, that means it's going to go straight up and down, so it forms a right angle, or it could be sideways, but the point is it's got to have an angle that makes it look straight across the other line. And if C is perpendicular to A, then B and C have to, by definition, be parallel to each other, okay? Because they are going to be not sloped any different than they are from the other one. They're both going to be sloped the same amount because they both have to form 90-degree angles. Okay, so this three parallel lines theorem we're going to use to do the second proof on this page, okay? Okay, so let's look at the information that's being given to us and what we're being asked to prove, okay? So it says B is parallel to A, so B and A right here are parallel to each other. And so the other one says, and C is parallel to A. So we're basically comparing both this line and this line in reference to angle A, or I'm sorry, to line A, okay? B is parallel to A, C is parallel to A. So let's just scan really quickly those statements and let's see if those are in there anywhere. The very first statement is, it's a repeat of what's in the given, so I can automatically fill in given for that one, okay? All right, now let's see if C is parallel to A is in there. Oh, look, it's the third one down. So that's also a given. So that already right there makes your steps a lot more easier, okay? A lot less to worry about in terms of writing in your steps, okay? So that information is given to us. So now let's just fill in what the rest of them are, okay? So they have already told us that lines are parallel. If lines are parallel, then we can use the postulates for corresponding and the theorems for same side interior and alternate interior to help us. Okay, so they've already told us this, that's a given. So the very next statement says angle 2, angle 2 is congruent to angle 1. Well, they've already told us that A and B are parallel. What kind of angles are angle 2 and angle 1 if A and B are parallel? Well, the answer is those are corresponding angles. One is inside and one is outside. Anytime as one is inside and one's outside, they're corresponding, okay? And so those are corresponding angles. So I would say for my reason, the corresponding angles postulate. And again, I'm abbreviating angles. I put the little angle symbol with an S, okay? Okay, so I've now proven that those two are congruent angles. Whoops. Okay, so now let me do the next step here. Let me erase that. Okay, so then they tell me that C and A are parallel. Okay, so for just a moment, we're going to ignore B, and that's in the middle. Okay, we want to focus solely on angle or line A, line A, and line C. Okay, so just for a slight moment, we're going to ignore, we're going to ignore angle or line B. Okay, just pretend it's not there. Okay, solely focus on A and C. Okay, so let's look at what it says next after it tells us that A and C are parallel. Angle 1 here and angle 3 here are congruent. So if you're looking at line A and line C, and then you compare angle 1 and angle 2, what relationship do angle 1 and angle 2 share in relationship to line A and line C? Well, the answer is one is interior and one is exterior, so those are also corresponding angles. So I would list the same reasoning you did for angle 1 and angle 2 when you were comparing B and A. Corresponding angles postulate. Okay? So those are also congruent, okay? So now for the easy part, okay? I want you to look at this statement here and this statement here. And I'm going to write them off to the side because it'll be real easy to potentially see this if I write it this way. So here's what it says. Angle 2 is congruent to angle 1, and angle 1 is congruent to angle 3. So then look at the next statement right here. Therefore, angle 2 is congruent to angle 3. What did they do? This is a property. Look, this is congruent to this, and this is congruent to this, so this is congruent to this. That's the transitive property. So that's what I'm going to write here. Transitive property. So since that's the transitive property, I want to look now at where those angles are located. Okay? Erase that. Okay, so look at where angle 2 and angle 3 are located. Angle 2 and angle 3. Okay, and then I want you to look at what the last statement says. Line B here and line C here are parallel. Okay, so remember we talked about this. If you're told that angles are congruent, or I'm sorry, if you're told that that lines are parallel, then you can prove that some of those angle relationships are there. Like the corresponding angles would say that if there are parallel lines, then corresponding angles are congruent. The converse of that is if we say that corresponding angles are congruent, then that can prove that lines are parallel. Okay? So therefore, that means that since they told us in this step that these two angles are congruent, and you can clearly see that 2 is located on top of line B, and 3 is located on top of line C, those look like corresponding angles. And if we already know that those are corresponding angles and they are congruent, then that proves, therefore, that line B and line C are parallel. That would be the converse of the corresponding angles postulate. And you can use that purple sheet to help you. That purple sheet tells you what the converses are. They're just reversed, okay? So the normal postulate says if two lines are parallel, then corresponding angles are congruent. The converse of the corresponding angles postulate says if two lines intersect and they form corresponding angles that are congruent, then that means that the lines that they are located on must be parallel. Okay? And that's like the second one on page 29, that purple sheet. If two lines and a transversal, meaning they cross, form corresponding angles that are congruent, then the two lines are parallel. So if angle 2 and angle 3 are congruent, which we proved here by the transitive property, and they are located on line B and line C, then line B and line C must be parallel. Okay? And I thought we were going to use, this really is actually a proof of the three angles, or the three lines, the three parallel lines theorem, okay? But we don't actually use that as a reasoning because we haven't proved it yet. We just proved it, okay? So now we know the proofs that you may need. And so the proofs are going to be two things I want to make sure you remember about proofs. Number one, you're going to want to make sure that you always look at the steps above, because the steps above may have led you to the step that you're on, okay? Then you're going to be looking for the only things you can use to prove these proofs are things you've already been proven or known to be true before. So you're going to use definitions. Like in the first one, we use definitions of supplementary. You might use the definition of right angles. And then you're going to use all the postulates and all the other theorems that we have proved. Okay? All right, so hopefully that'll help you a little bit on homework 3.2. Homework 3.2 starts at the top with a proof. It is not a 2-column proof. It's a paragraph proof. And technically, they've already given you the reasonings, but you're going to be based off of those reasonings. You're going to be filling in some information. Okay, I will talk to you guys later.